Hello, welcome to the second guide I've made about how to optimize VR performance for people mostly with the Reverb G2 headset. This might work for other Windows mixed reality headsets. It may even work for some Steam headsets. I'm not familiar with those, unfortunately, so this is really for people with the G2. I think the G2 is still the best headset you can get for Microsoft Flight Simulator, especially for the money. The VR Aero might beat it on resolution and a few other things, but it's a heavy headset and it's an extremely pricey headset. And actually, although this guide is designed for people who have a 3090, a 3090 Ti, a 3080 Ti, or 3080, or maybe even 3070 or 3060 series, it might even help for people on the 20 series as well. I actually now have a 4090, and my 4090 is still not pushing the total capacity of the Reverb G2, believe it or not. And so I do think it's a great headset still to have, even if you have a high-end PC. And again, as I said, it's designed for people who have a graphics card, certainly that can do RTX stuff. And the reason is, since SU10, which came out in September of 2022, we have DLSS, which in my opinion has completely changed the game again, in the same way that OpenXR Toolkit and some of the cool upscaling stuff and fixed foveated rendering stuff they introduced changed the game earlier in the year. DLSS, which is now enabled for RTX cards, has changed the game for people in VR. And the reason is you can up the resolution and the frame rate in VR and have a great performance increase with DLSS. I noticed this immediately. And in this guide, I'm actually going to prove to you that you can up the resolution and probably see more clarity than you imagined you could in your G2, whatever your hardware setup, including those with a 40 series. And take you through all the settings that got me there, but mainly I'm going to focus on the resolution and using DLSS. The first 10 minutes of the guide will basically be the settings I use, and then the rest of it will be explaining the different levers you can use, how DLSS improves clarity, and some of the other experiments I've done, and basically allow you to tune your system to work best for you. Okay, so without further ado, let's jump into the guide. The first thing I do is make sure your CPU is running at the capacity you want it to. So to get a little less stuttering, I would improve the performance of your CPU to the extent that you're willing to. Overclock it. I'm not going to go deeply into overclocking it, but I use Intel Extreme Tuning Utility just to check my overclocks and to before I apply them to BIOS. And I recommend you look into that, and each to their own. But if you improve your CPU for performance, you will get better performance in MSFS, most likely, even for those who are GPU limited, because terrain still has to load in, etc. The next thing to do is basically the same thing with your graphics card. I undervolt my graphics card and use a custom curve. I'm not going to go into detail how to do this because people will shout at me and say I've done it wrong or that you should never overclock your graphics card. Personally, I disagree. It's really up to you, but if you improve the graphics card performance, you will again see improvements in MSFS, and I think it's worth it. It's up to you to decide whether you think it's worth it. Next, make sure your NVIDIA settings are set up for maximum performance for Microsoft Flight Simulator. I turn off threaded optimization and set pre-rendered frames to 4. It works quite well for me, but I don't know how much of a difference it makes. In fact, I think the NVIDIA settings actually don't make that much of a difference. Another thing I would say is to turn off VSync. I've had some issues with VSync causing frame limiting based on the monitor you're using, not your headset. So I'm not entirely sure VSync when you're using VR is a great idea. I've noticed that more recently than I did this tutorial, but I would still recommend turning off VSync and seeing if that helps you with your stutters. You can fast launch Microsoft Flight Simulator. This is just a quick tip. It saves about 20 seconds every time Flight Simulator loads. If you have the Steam version, here is how to do it. If you have the Windows Store version, you can search online how to fast launch. You can write a little batch command and it will do it. So the main piece of software you really need installed to implement some of these fixes in headset rather than having to jump in and out of Microsoft Flight Simulator is OpenXR Toolkit. That brings up a menu inside an OpenXR app, of which Flight Simulator is one. And so that menu is activated using the F1 through 3 keys by default with control. You can change it. I've taken control off to make it easier. You can also take screenshots, which can create really beautiful screenshots of what you see in your head, in your headsets as well, and a bunch of other things. So this is OpenXR Toolkit. Highly recommend you install it, and I'm going to be using it for most of the rest of this tutorial, especially when it comes to changing resolution and playing about with things like that. So in Windows Mixed Reality settings, I think one of the most important things to do is to make sure that it's not turning on virtual displays. I think that's a waste of resources and not necessary. The other thing I would do is make sure that your headset display is set to maximum quality and full resolution. And then you can set the frame rate to 60 Hertz if you don't see flickering. I see flickering at 60 Hertz and I like it at 90 Hertz. I kind of wish this headset did 80 Hertz, which I don't notice the flickering at, but so be it. 90 Hertz is probably what most people are going to settle on. And then they can use multiples of that, say 45 or 30, in order to do motion reprojection if that's the look they prefer. Okay, the next thing to do is to look for OpenXR tools for mixed reality. Install it if you don't already have it installed. And make sure that the OpenXR Toolkit runtime is showing there. It will show as no vendor toolkit in API layers. That means that your OpenXR Toolkit is running successfully. One quick tip I would use to improve Flight Simulator load times and performance is to remove any bloat you don't need. You can remove planes, you can remove the default planes you don't like or don't fly, and you can remove scenery you don't use. All of that will improve load time and frame rates within the game if you happen to encounter things like scenery that would otherwise be custom scenery, or people's planes that you don't care about seeing their models. And that's one thing I do, and it's helped me a lot. So in Flight Simulator settings, before we get into graphics options, I turn off live real-world traffic to save resources. It's not something I use, and so I just turn it off. I switched since the last tutorial to using the same PC settings as I do VR. The reason is when I switch in and out of VR now, there's no change in settings. And I think some of the PC settings are actually used in VR subtly. And so if you want to pause the video at any time, you can see all my settings here. You'll notice that some of the settings are quite important, like texture resolution. If you have texture resolution set to low in PC and you spawn into the Milviz Corsair, you will notice the textures in the Corsair are also low, even if you have them set to ultra in VR. So I would recommend setting the texture resolution at least in PC settings to ultra if you plan on doing that in VR. Other things, for example, DX11 versus 12, it's only available in PC, but it does affect VR as well. So the fact that there are two different windows here can be a little bit confusing, it's worth perhaps just having them both set the same so there's no ambiguity about what might be causing issues for you if things aren't responding the way you want. Just after we pop into VR, I would highly recommend jumping into mixed reality settings and clearing environment data. This will prevent you having stuttering as you look around, caused by effectively the headset jumping position because it doesn't know where you are. Clearing environment data basically reconfigures the room you're in. And you might think, well, I'm always sitting in the same room, but actually the lighting changes. And this headset's not particularly good at tracking. It doesn't have proper laser tracked infrared tracking. And so it is worth doing that. I found that it helps me every time, and I do it every time I fly. So here we are in VR, and the first thing we're going to do is we're going to jump into the same settings I had before with DLSS off, motion reprojection on, and introduces watery artifacts. And we're going to take screenshots for the tutorial in order to show the difference in sharpness you can attain by using DLSS. And sharpness is something which you may not realize can be increased quite significantly inside the headset by increasing the render scale well beyond 100%. I'm pulling up the OpenXR Toolkit here using the F1 through 3 keys, and now we're going to turn off motion reprojection. And we have to restart the session twice. We have to turn off and on VR twice because of a bug. I don't know if that's an OpenXR Toolkit thing or something else. Once we've turned it off and on twice, we're rendering unconstrained now, not 30 frames per second locked, but as high as it can. And we're getting about 43 frames a second here over SF in the same location. Obviously the frame rate's always varying in the game, depending on what you're looking at, what plane you're in, cloud conditions, and a ton of other things. But we're giving a rough frame rate here of around 43 frames per second. And in a second, I'm going to take a screenshot and compare it, and I think it's basically the same. I feel in motion reprojection, it looks a little bit blurrier than without motion reprojection. And that's something that you might notice as well, and is really up to your tastes. Let's take a look again at the screenshot of that panel, and you can see here what it looks like. So now that I've shown you what the system was performing like in terms of clarity and frame rate prior to DLSS, I'm going to go into show you all my OpenXR Toolkit settings first. And the first one is I'd show expert settings in order to get a few extra settings. You can copy my settings from this if you'd like. I've played around quite a bit. I have a fixed foveated rendering setting set to custom. This will depend a little bit on what you can see. And so you can play around with the ring size and things like this. There are other tutorials on how to use fixed foveated rendering, but it does give you maybe 1 or 2 frames. It's not super amazing these days with DLSS, but it does help with a few frames, unless it's extremely aggressive, which starts to get in the way of the appearance. Now, I strongly recommend you use these presets, or at least try and use them as a baseline for your system, and the reason is the colors will look so much more realistic if you do. You can change the shaking reduction, which basically dampens the movement of the headset a bit. It might induce a little bit of nausea for you. Initially, I got over it, but it will remove things like seeing your heartbeat in the headset, which you might notice. And here we're going to change the resolution. So if you look at the system menu, you can actually override the resolution. Try cranking it up to 4300. This is on a 3090, by the way, so your mileage will vary. And then with field of view, I've actually changed my field of view quite a bit because there are parts of the screen I just don't see. You actually see more detail if you decrease the field of view, believe it or not. So if you don't believe me, decrease the field of view significantly and you will see things get sharper in the middle because of how the headset works. And then you may want to disable the ham mask, which doesn't seem to increase system load very much at all, but it gives you a tiny bit more peripheral field of view. That setting is called disable mask (ham). So that's the OpenXR Toolkit settings that I would recommend starting with and maybe playing with and understanding a bit better. But I especially think the color settings work quite well for you. The field of view settings might work. The fixed foveated rendering is really optional and gives you a few FPS improvement, but not a lot. So let's get rid of the menu and turn on DLSS. So in VR, switch from TAA, which was all that was available before, and go to performance. Try performance initially. Let's have a look. Now remember, we've upped the render scale from 3100 to 4300, okay? Around 4300. Again, your mileage may vary, you can change it. And we've turned on DLSS. And what DLSS does is it enables the game to render a much smaller sample and uses deep learning to increase the resolution by a certain percentage depending on whether you choose performance and stuff. Now look at this, we're getting 48 to 49 frames a second. And sure, we're not looking at the city right now, but it's still inducive of something. And look how much sharper it is. Here's the original image, and you can see how much more detail you can see visually in the headset by using DLSS, and with a higher frame rate. So you can actually even increase the resolution even higher. Let's try that now. Increase the resolution even higher. And I think these are my actual settings, so 4700 by 4600 performance. And I'm getting 43 frames a second, which is the same frame rate I got before. And again, look how much sharper this is than the original image that we had most of this year. And that gives you a sense of same frame rate, much, much clearer image inside the headset. And that's really how I'm using DLSS. Much sharper image with the same frame rate as before. Now with balanced, you lose a few more frames, and you may not notice the increase in quality. So let's go back and take another screenshot and have a quick look at that. So remember, balanced basically means we're generating more frames, real frames, or more resolution from the game, and using less DLSS upsampling. You can find percentages for this online. I can't remember the exact percentages. Now we're heading back to the city. And let's take a look at what balance looks like. That's what balance looks like. And if we take a look at this next to, yeah. Now let's switch back to TAA just to prove a point I made earlier in terms of the clarity. So now this is actually rendering the full resolution, obviously, so there's no deep learning involved at all. We get a terrible frame rate, but look at the clarity. Look at that compared to the original. Now you understand that 100% render scale, 3180 by 3100 is not the highest quality you can get in the headset. And if you think this is just me taking screenshots and doesn't matter in the headset because it's got a certain number of pixels, just try it for yourself and you'll see what I mean. You'll be blown away. If you've never tried this, you will be blown away by what's possible in certainly in your Reverb G2 headset. Again, the frame rate will be low, but it will show you that there's a lot more clarity you can get. And to me, clarity is probably more important than frame rate. I'd rather see a sharp image and slightly lower frames than really high frame rate, but I can't see anything, unless you're dogfighting, which you can't even do in MSFS. The world is what's beautiful, and seeing the clarity and the detail is what's beautiful. And the cockpit and the dials and everything else, the numbers, you may see detail in the cockpit you never saw before. Okay, so these are my final settings. DLSS performance, 4300 by 4200. I get about 47 frames a second, 46, which is around half the frame rate of the actual headset. Depends a ton on clouds and other things, but there we go. And I have shaking reduction turned on a little bit. You can turn it on more if you want or less. I would not have shaking reduction on with motion reprojection, and we're going to show you some other things. So this is now another setting you can use, same render scale, around 4300 by 4200. Again, this is for a 3090 with DLSS set to performance, motion reprojection on, which gives you fluid motion as you look down, but it gives you artifacts that look like kind of a watery artifacts all over the image. It might bother you too much. In fact, I've switched recently to go out of this because I realized the image is a little bit sharper without motion reprojection on, and I'm getting high enough frame rate now that I'm comfortable with that. Now I cannot look straight down below me and see the clarity in buildings anymore, but I don't do that often anyway, and I really enjoy the improved clarity I get from not using motion reprojection, but it's totally up to you. Another thing to notice is cloud settings make a big difference to and whether or not there are clouds to your frame rate. So we're getting a comfortable motion reprojection, 30 frames a second here, even in pretty heavy clouds over SF. At 4300 by 4200, which is a really great render scale. Now we're going to just show you what happens if we switch this to medium. We're going to go from a little bit below the frame rate to back into comfortable at 30 FPS. So that's something you can use if you are struggling with frames in a cloudy area. Highly recommend switching from high to medium, or ultra to high if you happen to be daring enough to use ultra clouds in VR. And that will get you definitely quite a few extra frames, like up to 20 to 30% more frames actually. That's how impactful clouds are on GPU performance. And we know that in VR, GPU is your limiting factor. I would turn off shaking reduction in that. I would turn off shaking reduction with motion reprojection. So in these last few settings, so in these last few minutes, I'm just going to show you how you can increase the frame rate even further by just reducing the resolution a bit. Now I'm setting it to around 4000 by 3900. I'm going back to motion reprojection off. So this is unthrottled frame rate. I'm getting sort of 47-ish, maybe a little bit 50, in the low 50s frame rate, depending on where I am. And this is just a quick explanation of how you can throttle the frame rate if you want. So if you're getting a lot of frames, you can lock the frame rate and you might get a smoother experience. Don't take the image in the background as example, because obviously this is a mixed reality preview, which is pretty bad, but it might help you to throttle the frame rate. I found my mileage varies. Sometimes it helps, sometimes it doesn't help, but you might be wanting to aim for a fixed frame rate. So the final things are you can change fixed foveated rendering. Fixed foveated rendering will change your frame rate a little bit. Mine was on custom before. If I set it to preset with a very narrow, which is extremely difficult to cope with, really, it's not super great, but you'll see my frame rate jumps to 54. If I go back to preset, it's 54. Custom comes down to 4950. And if you turn it off, it goes down to 47. So we're getting a frame rate difference of between 47 and 54 frames, depending on whether we have foveated rendering off. And by the way, what foveated rendering does is it blurs the edges. It creates a lower resolution image on the edges, which you might notice, and introduces sort of artifacts which you can see in the edge of your eyes, but increases the frame rate by a meaningful amount. So that's another thing you can do. I have mine on custom, so I can barely see it, but it has a few frames impact, which is always nice. Every frame counts in VR. And finally, now you've seen how fixed foveated rendering can change your frame rate a bit. I just want to go back into GPU overclocking and show that it does make a little bit of a difference, less than foveated rendering does, at least for the 3090. But I'm undervolting and changing the curve slightly here, overclocking marginally. But if I go to, if I have a GPU clock on, I'm getting about 52 frames a second. And as soon as I click that little reset button, it goes down to around 49, 51. So I have a little bit of an FPS impact. What's that, around 4%, maybe a little bit more. So it does make a difference, and I find it worth it. So every little helps with VR. So that's about it. Hopefully these were helpful. I would say in summary, optimize your GPU, optimize your CPU, check your WMR settings, make sure there's no strange windows opening in the background, check your NVIDIA settings, make sure you're on maximum power, install the OpenXR Toolkit, which gives you a ton of flexibility and power within the game. 100% render scale is not top picture clarity, as I hope I've proved to you now. You can increase the render scale as high as you want. Use DLSS, it's incredible. And then find the balance of your FPS, cloud settings, resolution, motion reprojection, etc. And figure out what works best for you. These are all levers you can use to make the best experience in VR. And hopefully you do improve your experience and you've learned something. Thanks for sticking around, guys. Do like and subscribe if you like the videos. And yeah, check back soon for more. Thanks again.